So now my goal is to give you some examples of use cases for exceptions. So I probably have tried to fit too many examples in one small program on the left, so that made it maybe a bit harder to read. But if you use exceptions sparingly in the right places, I think it can greatly improve the readability of your programs. So let's see how this works. Well, in a normal way of operation, if you want, we define two functions, but then we ask for some data, input it as a string, and we evaluate that data into a Python object. Of course, we could already have errors there, and those errors will be caught. And instead of just saying there is an error, we'll try to give some helpful error message and then continue from there. Now, if this works out, if this is actually successful, then we'll execute fake inner product on this evaluated data. So let's see what fake inner product does. So first, I run Python exception examples, and then I enter data, and I want a list of tuples. So there we go. I have a list of tuples. And this returns 14. Why 14? Well, it will be the sum of 1 times 2 and 3 times 4. So this is what it does. It takes every tuple, multiplies it out together, and then takes the sum. So how does it do that? Well, if it's actually quite simple. Fake product essentially just does the product of the two items, and the summands actually will take the fake inner product, will map fake product to every item of the list, and then will generate a new item of type summand type and sum the summand to this new item all the time, and then return the temp. Okay, and in the normal operation, you can just ignore all the except parts. Okay, so this might look a bit complicated, especially here for the generation of a new item if you want. But the main reason is that we want to allow things like this. So we want to allow things like this. So multiplication by something else than an integer, and this will give me 1 time this bit and then 4 times that bit, all summed up together. Okay, so the interesting bit here is not what the program does, but how the program reacts when there are mistakes. So the first type of mistake that could happen is that I enter something nonsensical. So I enter just some crap here, and here the program will actually return a name error. So I didn't catch that. This is not caught, but it returns a name. Oh no, sorry, it is caught by exception here, exception as E. And well, yes, this was valid syntax. The problem with this valid syntax is that it created a name. This is a valid variable name, and this variable name was not recognized in the current state of execution, so it raised an exception, which was a name error. And this error was actually that this name is not defined. Okay, so let's try another way this could fail. So what if we try to enter something like this? We don't close the bracket. So in this case, it creates a syntax error because this is not valid Python syntax. And I corrected, or I amended the error message to give some examples of correct syntax. All right, so this would be better in terms of error messages. Okay, so let's say now that this actually, what I enter evaluates to a correct Python object. So I enter 1, 2. Well, this will not work at some stage because I was expecting a tuple here instead of just 1. So I'll go in and do the whole thing. And here, at some point, I'll catch that the type of the item is not a tuple thanks to the assert. And so assert raises, so this statement here is a shortcut for if this is not true, then raise an assertion error with this error message. Okay, so this error message you see here, expecting a tuple instead got 1. Okay, so another way to create an error like this is if I was entering something that's not of length 2, but of length 3. So here it will say, oops, I actually have a mistake here in my error. Yes, so let me correct that. I had a mistake in my exception itself. So 1, 2, 3, 4, 5. Okay, so here I raised the assertion error, and I was expecting an item of length 2, and instead I got 1, 2, 3. Okay, and it's actually a tuple of length 2, not an item. Okay, so those are different types of things that could happen. Let's look at another exception that could occur. What if I try this? Instead of entering 2 things that can actually multiply, I enter 2 things that cannot be multiplied, like this list and this string. And so it says the 2 components cannot be multiplied. All right, and so you can see how this whole works out. I could even have some here. I could arrange to have in several items, and the first item will produce a list, and the second one will produce an integer. And in this case, I've decided to, so this is caught here when I try to add to the previously existing summand, or the partial summand temp. So this creates a type error, and then I print the following: a summand is of incompatible type to the original one. I got a type int while I was expecting a type string that I inferred from the very first, so I skip that summand. Okay, so you only see 4 times that is displayed, and the 4 times 5 is forgotten. Another error that can be produced is here, the index error, because I could access the 0th summand. And so here, this would occur if I enter the empty list. And in that case, I've decided to just return none. And you see this here. So admittedly, this is not a very useful example, but I hope you see the different use cases for exceptions. And you can see that this delegates all the error control, if you want, to the bottom in general, pushes it to the bottom in a separate block that you don't even have to read in normal operation of the program.